Today we're going to talk about transformations. Transformations to trig graphs are the same as transformations to any other function, okay? Except there's one difference here, is that we have a thing called an amplitude versus just a stretch. And we're going to get to that, okay? So we're going to start out with the sine function, y equals the sine of x. And then want to know what happens when you add d to the end of it. Well, let's talk about the function itself, okay? When I graph the parent functions, I always put in my favorite angles, which are on the axis. So you have 0, you have pi over 2, pi, 3 pi over 2, and 2 pi. Oh, I've got the 2 in there. The sign here is 0, it's 1, it's 0, it's -1, and it's 0. When I graph the parent function, it starts at 0, it goes up, goes down, goes back up, keeps going. Correct? Correct. Hopefully you're good at these by now. All right? You've practiced. Now, I'm going to take that function, y equals the sine of x, and I'm going to add 2 to it. Well, that 2 gets added to this value right here. So this becomes 2, 3, 2, 1, 2. So this point right here goes up 2. This one goes up 2. Up 2. Up 2. Okay? And all I've done is shift the whole graph up in the air. All right? Now, you ask yourself, what does it change? The domain or the range or both? Well, in this case, it affected the range. Okay? So my range changed because this one is from -1 to 1. I now have it going from 1 to 3. But will it do the same thing for all trig functions? Think about the tangent function. So I'm going to get rid of the sine and put in the tangent. The tangent graph goes like this. It goes to 0, 0, and it has asymptotes at pi over 2. And the graph goes like this. Now, if I add 2 to the y value, it's going to shift this up and this up and this up. So my new graph ends up here. Did it change its domain? It didn't change its domain. And did it change its range? No, because the range on this case was all reals anyway. And it doesn't matter where you start and where you end. Okay. All right. Alrighty, so that's going to be the same for all of them. That's an easy transformation. All right, they're going to take this one, and you have an x minus c. Well, first I want you to think about y equals x squared. Whoop. And then change your mind and get y equals x minus 2 squared. So the function's squaring something. That's going to shift it over 2 to the right. All right? Guess what? It does the same thing on trig functions. So, y equals the cosine of x. If I make that same chart, you have 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is 1, 0, -1, 0, 1. And my graph of this cosine function starts here, goes down, and comes back. Remember, it goes on forever. And this is 2 pi, and this is pi. This is 1 and -1. Now, they're saying to shift. Phase shift, it's usually in terms of pi. Okay? So my new graph is going to be something like y equals the cosine of x plus pi over 2. All right? So what happens is, remember, this is the angle. If I want this to be 0, and I'm going to add pi over 2 to it because I'm taking this cosine as 0, this is negative pi over 2. This would be 0, because if I plug in 0, then I get to that. So basically what's happening is I'm moving everything over a half a pi. Okay, so this point came over here to here to here, and the whole thing shifted That's why it's called a phase shift. We shifted it. Did it change the domain and range? No. Not on the cosine graph, and it won't change it on the sine graph either. All right? Think about tangent, though. Tangent's going to be a little tricky because when you do a phase shift, you're moving your asymptotes. So if I've got the tangent of x plus pi over 2, well, let's draw just the tangent first. All right, so let's back up and put the tangent in here. Y equals the tangent of x. It's the green one. Okay, this is pi over 2. Goes through 0. You have negative pi over 2. Okay, you should know how to draw these graphs this fast, people. Okay, now I switch to the blue. It's shifting it to the left, pi over 2. So this asymptote comes over here. And this asymptote moved over here. And that 0 went into here. Okay, so let's draw it when they're not on top of each other. So my blue graph, we just moved our asymptote from here to here, and over to here, and here. The period's still pi, okay? But I just changed my domain. My domain is now all values of x such that x is not equal to pi k, because we shifted it. Okay, so be careful. The range is still all reals. Okay? All right, phase shift. Next, period. We're putting a letter in front of that. Okay? It's not outside, it's inside. Okay? What it affects is the period. And remember, period is how often it repeats. So let's do this. Y equals the sine of x, my parent graph. And it takes 2 pi to repeat, right? Now, if I change that graph to y equals sine of 2x, this is what you have to remember. The new period equals the old period, which in this case is 2 pi, divided by b. And by b, that's this number here. That's b. Here, oops, sorry. Let's erase that and use highlight instead. Okay, that b and that b are the same thing. So in this case, it's a 2. So I take 2 pi divided by 2, and you get pi. So instead of taking 2 pi to repeat, it's going to repeat in half that time. Okay? I just crunched the whole thing down. I didn't shift it. It just repeats faster. Now, things to keep in mind. 2 pi. Which trig functions have a period of 2 pi? Okay, the period of 2 pi is sine, cosine, cotangent, no, not cotangent, cosecant, and secant. Those are 2 pi. All right? Let's take this out of here. And the period of pi is tangent and cotangent. So your rule that you should remember is the original period divided by b. Gives you the new period. Okay? That's a lot to think about. Think about it. Did it change the domain and range here? No. Will it change the domain and range on cosecant and secant? Yes, because they have asymptotes. So you say domain if asymptotes. Asymptotes. All right, so let's do it. Trig function so you can see what happens, okay? Oh, wait a minute. Good thing that didn't work. I want to leave that. Good. All right. So the tangent graph. Ooh, let's do it in brown. Ooh, come back. Brown. All right. My tangent graph. Parent graph. Pi over 2. Negative pi over 2. All right. So if I have the tangent is 2x. Actually, we use thetas. Theta is the Greek letter. Usually we use a theta. So you know you're dealing with an angle. Anyway, the original period is pi. So the new period is equal to pi over 2. So it only takes a half a pi. Now I didn't shift anything. So what happens is my asymptotes are now crunched in here. They're at pi over 4. So let's take these out of here. All right. And it's now, these are at pi over 4. So it changed my domain. So my domain now is x. X can't equal pi over 4. And how often does it repeat? We just have a new period, remember? Pi divided by b. So now instead of adding pi over 2, we're adding pi k, we're adding pi over 2k. Ooh. Stop. Pause on that and think about that, y'all. You moved the asymptotes because the time it takes to repeat, and then what you're adding here is different. You're going to have that same problem with secant, cosecant, cotangent, but today we really just want you to know what all of these initials do. We're going to spend day 2 on transformations practicing graphing a lot, all right? But today it's really to just figure out what's happening to your graph, okay? All right, phew. All right, the last thing is we have a letter out front. Usually if I have y equals x squared, and then I have y equals 2x squared, that 2 stretches the graph, makes it tall and skinny. All right? Well, it's going to do the same thing. It's a vertical stretch, if it doesn't have amplitude. So that is tangent, cotangent, secant, and cosecant. Its amplitude for sine and cosine. Oh, that's what it says right there, for sine and cosine. That's important. All right? Amplitude. What are we talking about with amplitude? Well, the parent graph of the sine function goes whoop, 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 is how far away from my center line. Okay, oh, dang it. So I'm going to call this my center line. Okay, it goes 1 unit up and 1 unit down. So the amplitude is 1. But if I change that graph, well, we don't need this here because we're not doing those. To y equals 2 sine x. I'm multiplying the y values by 2. So this is now going to move up to here. 2 times 0 is still 0. 2 times negative 1 is now negative 2. And my graph just stretched like this. But on a sine and cosine graph, we say that the amplitude changed. The distance from the center line to the top, or the center line to the bottom, is now 2. Okay? Oh, we don't need that right there. So what did it change? Your range. So my range now, instead of going from negative 1 to 1, now goes from negative 2 to 2. And this also, we have to remember that this could be negative. So if I change this equation to negative 2, what did a negative do to y equals x squared? Flips it over the y-axis. So that's what it's going to do here, is it's going to flip this point. Oh, why didn't it turn red? There we go. That point's now going to be down here. 0 is still 0. That one flipped up here. Okay. So that reflects across y-axis. but the amplitude is the absolute value. Okay, so let's write that down. Amplitude, where should we write it down? Well, let's get rid of a mess. Okay, amplitude is the absolute value of A. All right, you're never going to have a negative amplitude. So here's my transformation equation with all of the variables in it. You have A, B, C, and D. A does amplitude or vertical stretch. B is a phase shift. C is a horizontal. No, I was wrong. This is a shift, which is a phase shift. I lied. That's a phase shift. This, silly, should be the period. And remember, it's the new period is the old period divided by B. And D is vertical shift, or vertical displacement, whatever you want to call it. Alrighty? By factored out, they mean if I have the sine of 2 theta plus pi, before I tell you what B and C are, you have to factor this outside. So you have 2 theta plus pi over 2. So my phase shift is going to be negative left pi over 2, and the period changes by 2, so you end up with just pi, 2 pi divided by 2. Okay? All right, so here's some of the stuff it's going to ask you on your homework. It asked you for the amplitude, which is 3, the period, which is 2 pi divided by 2. Okay, the phase shift is, they didn't leave me enough room, left pi. And the vertical displacement in this case is none. And fill in the blank. Don't leave it blank. I'll mark it wrong. Write something in there. None. 0. Okay. My domain is still all reals. My amplitude is now, because I didn't shift up or down, goes from negative 3 to 3. All right. Amplitude 4. The period is 2 pi divided by 1/3, which is 6 pi. Phase shift is left pi. Vertical displacement is down 2. Okay? And tell me down, up or down. Don't tell me negative 2. Well, this is going to be a little tricky because I just went down 2. All right, so think about your graph. You went down 2. So that's your center line. Let's make that a center line like this. Okay? And then you gave it an amplitude of 4. So from here it's going up 4 and down 4. And this is negative 2. So negative 2 plus 4 gets me to 2. And negative 2 minus 4 is negative 6. So my range goes from negative 6 to 2. Ooh, think about that. And this is still all reals. Oh no, I scribbled on everything. I gotta erase it. But I can't do this without thinking. Without a picture, sorry. All right, amplitude. There's a negative there, which means it's gonna flip over. So if I was gonna draw this graph, which I think we should, it's gonna start here. It starts at 1. Instead of starting here, it's gonna start at the bottom and go up. All right, so this is 3. The period is 2 pi divided by 3. So let's erase this. It's kind of getting my way. Okay. Phase shift, I got to factor that 3 out. So it's 3. This is theta plus 2 pi is left 2 pi. Vertical displacement is up 7. Oh, man. Okay. So let's do this. So the graph usually started at 1, and we're going to flip it over to negative 1. And then the displacement is 7. So you go from negative 1, you got to go up 7, so you get to what, 6? So my center line of my graph actually is up here at 7, okay, because it just moves your center line. That moved your center line, and I'm going up, down, and back, down again. But what did I do? Oh, this is what next lesson is. But I'm only doing this because we still have to go left 2 pi. Oh, it's going to start in the same place. But the period is different. So it's telling me that this is 2 pi over 3. And this is pi over 3. But the whole reason I was doing this is that your domain is negative infinity to infinity. And your range is now going from... Oh, and then we have to stretch it 3. Oh, man. So this is at 7. 1, 2, 3. So that brings it down to 4. And up here to 10. Oh, wow. So this goes from 4 to 10. Wow, I've really blown you away, haven't I? Sorry. Oh, that goes here. 4 to 10. Those are tough questions if we're not going to graph first. All right, well, that's the way it is. I'm following direction. Come to the Zoom and we'll do a better job, okay? So this is wrong, in the wrong spot. Blah, 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 blah. All right. It went down 2. We didn't stretch it. So your center line's here. You brought it down 2. So now I'm going to go from negative 3 to negative 1. Amplitude is still 1. The period is 2 pi. The phase shift is left pi over 3. And the vertical displacement is down 2. This should have said up 7. Okay. Let's do the tangent. Amplitude is not applicable. NA. The period, remember, is pi. So pi divided by 1 is still pi. Phase shift is left pi over 3. Vertical displacement is down 2. The range is still all reals. Same with this one. This, what happened is your asymptotes were here at pi over 2, and you're shifting it that way, pi over 6. To pi over 3. So that's what, 3 pi over 6, and you started at, no. This is 2 pi over 6. We started at 3 pi over 6. So I'm ending up at pi over 3. So my domain is x cannot equal pi over 3, and the period's the same. That's tough. Okay, next. Have an amplitude of 4, a period of 3 pi, a phase of pi over 6, and vertical displacement. All right, if it has amplitude, it has to be a sine or cosine graph. If it's 4, it could be plus or minus 4. So I want you to put both the plus or minus. Then write sine or cosine, I don't care. All right? If the new period is 3 pi, so the new period equals the old period, which is 2 pi, over b. You multiply by b and divide by 3 pi. So you get 2 pi divided by 3 pi. So b is 2/3. If you put it on the outside, you don't have to worry about it. A phase shift of pi over 6. So you subtract that, vertical displacement of 1. Okay? Amplitude of 2. Y equals plus or minus 2. The period is pi, the new one. So pi is equal to 2 pi divided by b. So b must be 2. Well, let's make this one a cosine just because I can. Cosine of 2 theta minus pi over 4 minus 3. Okay, amplitude, those are all the same. I want you to practice finding your periods, though. Right, the new period is pi over 3 equals 2 pi over b. Well, if you cross multiply, you get b times pi equals 2 equals 6 pi. So b is equal to 6. There you go. All right, so let's do this last one here. Those I'm going to let you do. A vertical stretch, so you know it's not a sine or a cosine. So let's make it a tangent. didn't say anything about flipping over, so it's positive. A period of pi over 2. So remember that this is the new one. The old one was pi, so that's a 2. Theta minus pi over 2. Vertical displacement of 1. And that's all there is to the lesson, and that's all there is to your homework. That was really quick. Pause it, replay, wind, go backwards. Don't worry too much about graphing them today, because we're going to spend a lot of time graphing next class. But you sort of need to graph in order to do these domain and ranges. Alrighty? Good luck.